and welcome to another video. The function f is defined by f of x equals to x cubed minus 3. A. Find f of 0. B. Write down the solution of inverse function of x equals to 0. C. On the same axis, sketch the graphs of y equals to f of x and y equals to inverse function of x for -5 less than x less than 5. State the number of solutions of the equation f of x equals to inverse function of x for 0 less than x less than 5, and that's D. Okay, so what I will do first is I'm going to write this, what we are given. Solution given f of x equals to x cubed minus 3. Now to find f of 0, what is the value of f of 0? Okay, what is this equals to? When x is equals to 0, which means when the value of x is equals to 0, what will be the value of f of 0? So now f of 0 will be equals to 0 cubed minus 3 because the value of x is 0. So when the value of x is 0, f of 0 will be minus 3. So this is the answer because 0 cubed is 0. B. Write down the solution of inverse function of x equals to 0. Okay, what I would do in this case is, now I wouldn't want to use the original function to write an expression for the inverse function of x. Now let me use one of the key properties of inverse function. Yeah, so using the key property of inverse function, okay, and that is the property which states that if f of x is equals to y, okay, this implies that the inverse function of y will be equals to x. So which means inverse function of x equals to 0, okay, implies that f of 0 will be equals to x. And we know that the value of f of 0 is minus 3. So which means that the solution, this is equals to minus 3. So which means that the solution of inverse function of x equals to 0 is 3. The answer is minus 3. Is minus 3. Okay, all right. C. On the same axis, sketch the graphs of y equals to f of x and y equals to inverse function of x for -5 less than x less than 5. Okay, so what I would do in this case is to be able to sketch the graphs of the original function and its inverse. Okay, I'm going to now I'll need to first find the x and y intercept for each, x-intercept and y-intercept for the original function, x-intercept and y-intercept for the inverse function of x, which is the inverse of f of x. Okay, so now I'm going to write this again. We have f of x to be equals to x cubed minus 3, x cubed minus 3, x-intercepts for the original function. You know, the value of x, when the value of y is equals to 0 will be our x-intercept. So which means when y is equals to 0, when f of x is equals to 0, we have 0 to be equals to x cubed minus 3. So I'll carry this over to the left hand side. This will be 3 equals to x cubed. Okay, now I can take cube root of both sides. Okay, take cube roots of both sides, and this will be cube root of 3 equals to cube root of x cubed. Cube root of x cubed. Okay, now cube root of x cubed is x. So this will be x equals to cube root of 3. Now cube root of 3, that will be, now for square root of 3, that's 1.732. Square root of 2, that's 1.414. Now cube root of 3 should be 1.44. Yeah, 1.44. So this should be 1.44. So which means x-intercept will be 1.44. That is, the coordinate will be x is 1.44 when y is equals to 0. That's it. All right. For y-intercept, that is the value of y when x is equals to 0. So which means when x is equals to 0, what is the value of y? So it means that because we know that y is equals to f of x, which is equals to x cubed minus 3. So when x is equals to 0, then this will be, then it means y will be equals to 0 cubed minus 3. So that the value of y will be minus 3. So y-intercept will be 0 and minus 3. So I'm going to be using the values of, that's x-intercept and y-intercept, to sketch the graph. I don't want to go, beyond this. I don't want to I don't want to use other values apart from this. All right. So for inverse function of x, now here I use one of the key properties of inverse function, to write down the solution for the inverse function of x equals to 0. So what I will do now is I'm going to write an expression for inverse function of x in terms of x. Okay, yes, in terms of x, because now the inverse function of x becomes y. All right. So what I will do is, let me write an expression for the inverse function of x. Expression for inverse function of x. So from the original function, we have f of x equals to x cubed minus 3. Now I can swap x and y in this case. That's another way to write inverse of a function. You first swap. So the first thing to do is to swap x and y. Of course, we know that this is y. So this will become x, and this will be y cubed, then minus 3. So then I'll carry this man over to the left hand side, okay, from the right hand side. So we have this to be x plus 3 equals to y cubed. Let's not forget that the inverse function of x is our y. Is going to be y in this case. All right. So again, I'm going to take cube roots of both sides. Cube root of both sides. So this will be cube root of x plus 3 equals to cube root of y cubed. So which means that y will be equals to, I know that the cube root of y cubed will be y. So y will be equals to cube root of x plus 3. Okay, where y is what? Inverse function of x. So which means inverse function of x is equals to cube root of x plus 3. So that's the expression for the inverse function of x. Okay, now x-intercept, which is the value of x when y is equals to 0. So it means that when the value of y is equals to 0, okay, when this is equals to 0, what is our x-intercept? So that means we have 0 equals to the cube root of x plus 3. So in this case, I'm going to cube both sides. I'll cube both sides. So 0 cubed will be 0. This is 0. Cube root of x plus 3. That will be x plus 3. So I'll carry this over to the left hand side so that the value of x will be minus 3. So which means x-intercept will be minus 3 and then 0. That is when y is equals to 0, x is minus 3. Now let's find out what will be the y-intercept. Y-intercept. So for y-intercept, it means the value of y when x is equals to 0. So what is the value of the inverse function of x when x is equals to 0? So this will be cube root of 0 plus 3. And this will be cube root of 3, which is equals to 1.44. Nice, 1.44. So which means the y-intercept will be 0, then 1.44. Okay, let me use this space. So now the sketch of f of x, that is sketch of y equals to f of x and y equals to inverse function of x. Okay, so this is the y-axis, positive y-axis. This is the negative x-axis. This is the positive x-axis. This is the negative y-axis. Okay, so for f of x, let's start with f of x. When the value of y is 0, x is 1.4, 1.44. This is it here. We're using this. X is 1.44. So let's say this is 1, 2, 3, 4, 5, then 6. And let's say this is also 1, 2, 3, 4, 5. This is negative 1, negative 2, negative 3, negative 4. This is negative 1, negative 2, negative 3, negative 4, negative 5. Okay, so when the value of x is 1.44, let's say this is 1.44, then y is 0. That's 1.44. When the value of y is negative 3, when the value of y is negative 3, x is 0. X is 0. Now, we know that for cubic function, okay, the graph of a cubic function, this is what it looks like. Okay, this is what the graph of cubic function looks like. So which means that in this case, we have a parent shift function. Okay, we have a parent shift function where we have y equals to x cubed minus 3. So this, which means that the transformation in this case is that the this is a parent shift function. That is this shift. This one means that it shifts down by 3 units. Okay, that is y equals to x cubed. That is the parent function shift down the vertical line, okay, by 3 units. Down, it will be down will take negative value. When it is up, it will take positive value. So it means that I'm going to go this way. I'm going to go this way. Yeah. Okay. So this is the sketch of y equals to f of x. Okay, we have this to be that of y equals to f of x, which is x cubed minus 3. Nice. Okay, so for inverse function, this function, we have a cubic function. Now, one thing about function is that now the graph of inverse function, okay, the graph of inverse function is a reflection of its original function over the diagonal line in this case. Or we can say the graph of the inverse of a function is a reflection of the original function over a vertical line where y equals to x. That's why when I wanted to derive the expression for inverse function of x, okay, I swap x and y. I swap x and y. Yeah, this one. Now, so for cubic function, okay, let's look at what it looks like. So for cubic function, for y equals to cube root of x, for cubic function is going to be this way. Yeah, this is the graph of cube root function. That is cube root function. That one is cubic function. So this is cube root function. So now, using the x and y intercept, so we have that when for x-intercept, when the value of y is equals to 0, x is minus 3. Okay, this guy. Then when the value of x is equals to 0, y is 1.44. This other guy. So this is 1.44. This is also 1.44, or cube root of 3. Okay, so I'm going to go this way. I'm going to go because this is an open interval between 0, that's between -5 to 5. It will be within, that's for an open interval. So this is, I'm going to go this way. So this is the graph, the sketch of so they meet here. So this is for the inverse function, that is cube root of x plus 3. That's the sketch. Okay, the last question. State the number of solutions of the equation f of x equals to inverse function of x for 0 less than x less than 5. Very simple question. It's just for us to test values between 0 and 5. Okay, and when we test values in this case, this is an open boundary case. Okay, that's open boundary, so it means that, or the open interval rather, open interval. So it means that I can use intermediate value theorem, to find the number of solutions. It should be one solution. Yeah. Now, because I said that the graph of the inverse of a function, okay, is a reflection of the original function over the vertical line where y equals to x. Let me write that. For D, solution D. Now, note the graph of inverse function, that is inverse function of x, is a reflection of f of x across a vertical line y equals to x. So which means that f of x will be equals to x, and that will make that with this we should be able to determine the number of solution. Yeah, we should be able to determine the number of solution in this case. And let me explain what happens here. This function, okay, is strictly increasing. Why the inverse, okay, the inverse stays well within the range. Yes, it stays well within the range. That's why we have 1.44 when the value of x is 0, 1.44 when the value of y is 0. So which means, the range of the inverse of a function is the domain of the original function. the domain of the original function will now be the what? The inverse will now be the range of the inverse. That's its inverse function. That's it. Okay. So in this case, we have f of x to be x cubed minus 3. Then this is equals to x. So that this will be x cubed minus x minus 3 equals to 0. Like I said, we're going to use the intermediate value theorem in this case, just like test values. Okay, test values between 0 and 5, this interval 0 and 5. So let me use one. Okay. So when x is equals to 1, so it means that we have 1 cubed, I'm using this, minus 1 minus 3 equals to 0. 1 cubed is 1. 1 minus 1, that will be 0. So this will be minus 3. So this is negative. So this will be minus 3. Okay. This one is negative. Okay. Then when x is equals to 2, when x is equals to 2, that will be 2 cubed minus 2 minus 3. 2 cubed is 8 minus 2, that will be 6. 6 minus 3. 6 minus 3, that will be 3. So this is 3, and this is positive. So which means that there is exactly only one solution. There is exactly only one solution. And we've come to the end of this tutorial. The noblest pleasure is the joy of understanding. Bye-bye.